Okay, so if I drive the 160 kilometers from Sydney to Newcastle in 2 hours, my average velocity is 80 kilometers per hour, but my instantaneous velocity during the journey, as displayed on the speedometer, may range from 0 when I stop at this traffic light to 110 kilometers per hour on expressways. Thus, an average velocity corresponds to the gradient of a core of the displacement time graph, and so an instantaneous velocity corresponds to the gradient of a tangent. Alright, so what we do is we're going to fill out some information about instantaneous velocity and speed. From now on, velocity and speed correspond to instantaneous velocity and instantaneous speed. We'll just leave out the word instantaneous. But if I say average velocity, it means average velocity. But if I say velocity, immediately it means instantaneous velocity. Alright, so let's fill out some information about velocity. Velocity is a measure of rate of change of displacement with respect to time. So V is dx over dt. Another symbol for V, Another symbol for V will be x dot. Okay. A common unit for V is meters per second. Write it down. So velocity and speed alone will mean instantaneous velocity and instantaneous speed. Okay, and if velocity is positive, we say the particle is traveling in the right direction. Alright, next. If V is less than 0, we say it's traveling on the left direction. And if V is 0, we say the particle is at rest, which is stationary. And it stops. This also occurs when the particle reverses its direction. The formula for instantaneous speed is the absolute value of V. Okay, so let's summarize all the terminology we've done so far. We have 4 formulas so far. So average velocity is x2 minus x1 over t2 minus t1. Is the gradient of the chord. Gradient of gradient of chord. Gradient of chord. Okay. So whereas instantaneous velocity is the derivative. This is the gradient of tangent. Okay, write it down. Gradient of tangent. So that's the differences between them. Let me write it again. T2 minus T1. Okay. Right, next we have average speed. Average speed is distance over time. And whereas speed is the absolute value of V, which is absolute value of dx over dt. Okay. So speed and velocity are very similar, but average speed and average velocity are completely different. One is distance over time, one is the gradient of the chord. Alright, good. After we do this, we're going to continue to do some questions. Okay, good. Alright, so now the first question we'll do is that's in your textbook is to work out the graph for the velocity. So this is a displacement time graph, x against time. We're going to draw the graph of velocity. So that means we're going to draw the graph of the derivative, dx over dt against time. And the easiest way to do that is to start with the stationary point. There's 2 stationary points at about here and about there. 1, 2, 3. So 2 stationary points. And then after that, it's going upward, positive. So therefore, it is above the x-axis. So that means in terms of the graph, it's going to be somewhere here. And then it's going downward. Right, so it's going to be below the x-axis. And then it's going upwards again, going upwards, so it's increasing. So it's going to be somewhere here. Okay. Right, yep. So what you do is your graph will be inside this region. So let's draw the graph. So your graph will look like it's going to be positive, and then negative, and then positive again. So that's your graph. Okay. Right, write it down. Alright, okay, let's move on. Hopefully all finish. All finish. Yep. Okay. Let's look at example. A particle moves on so that its distance in meters from origin at time t is given by this formula. Differentiate to find the velocity function. So velocity is dx over dt, and that equals to 1/3 times 3t squared minus 6 times 2t plus 27 minus 0, right? So therefore it becomes t squared minus 12t plus 27. Okay, so v is just the derivative of x. And once you find the derivative, we can answer these questions. Find the displacement, distance from the origin, velocity and speed at 2 different times. Okay, so we start with the x, which is the displacement. X equals to, when t is 0, you substitute t equal to 0 in there, so you get negative 18. Okay, negative 18. And the next one is distance from origin. So the distance from origin will be positive, so you just write 18. That's meters, meters, meters. Okay. And then you got velocity. Velocity is, you substitute t equal to 0. V, this is equal to, or you can say distance from origin is just absolute value of x. And v will be, we substitute t equal to 0, that will be 27. 0 plus 0 plus 27, you get 27 meters per second. Okay? And the speed is the absolute value of v, which is 27 as well. Okay? Alright. So the speed just tells you how fast it's going, how fast. And velocity tells you 2 information, tells you how fast and which direction. So it's positive means it's moving on the right, moving right. And then it's also not only it's moving right, it's moving at this speed. Okay, it tells you 2 things, the direction and speed. Whereas speed just tells you how fast. Velocity tells you 2 things, your direction and your speed. Okay? Alright. After we do this, we're going to, maybe don't write it here, it's covering, and direction. Direction. Okay, good. And then we're going to find out the displacement when t equal to 3. So at t equal to 3, we substitute 3 into x. 3 into x, you get 1/3. 1/3 times 3 cubed minus 6 times 3 squared plus 27 times 3 minus 18. Okay, good. And then use your calculator. Calculator will be 9 minus 6 times 9 plus 81 minus 18. Okay, 18. So that will be 18 meters. Also 18 meters. Okay, that's positive. And distance from origin is also 18 meters. Okay. And after we got displacement, we get velocity. Velocity is when you substitute 3 into the formula. 3 squared minus 12 times 3 plus 27. That will be 936 minus 12 times 3. That will be 0. So you must have stopped. And the velocity is 0, speed is also 0. Okay, meters per second. Oops. Okay, good. All right, done. Any question? Good. All right, let's move on. So, finding when a particle is stationary at rest when the velocity is 0. To find when the particle is stationary, put v equal to 0 and solve for time. So we're going to find the times when the particle is stationary. So that means we write down v. V is equal to t squared minus 12t plus 27, and make that equal to 0. So you have to solve the equation. So to solve it, you factorize the quadratic, or you can use the quadratic formula if you can't factorize. And that will be -3, -9. That works. So t minus 3, t minus 9. So therefore, it stops after 3 and 9 seconds. That's when we stop. Find the times when we stop. And the distance from the origin at these two times. So we've already got when t equal to 3, x equal to 18. We've got it from the previous part. When t equal to 3, x equal to 18 from part B. And we just have to work out the displacement or distance from the origin. So therefore, the distance from the origin, distance from origin equal to 18 meters. And then t equal to 9, you find out x. So x will be, we have to redo. So the equation will be, so 1/3 times 9. So you get 9 to the power of 3 divided by 3 minus 6 times 81 plus 27 times 9 minus 18 equal -18. Okay, so -18. So therefore, distance from origin equals to 18 meters. Okay, done. All right, good. All done. And today we also want to go through acceleration, so we'll need to go through another two pages, page 7 and 8. Right, let's go through. Okay, page 7 and 8. All right, we'll move on. Next page. Okay, good. What is acceleration? Acceleration is a measure of rate of change of velocity. So velocity is the rate of change of displacement. Acceleration is the rate of change of velocity with respect to time. That's the definition of acceleration. So the unit for A is meters per second, rate of change of speed, of velocity of time. So meters per second. So what does that become? It becomes meters per second square. So the unit for acceleration meters per second square. Okay. So therefore, it's dv over dt, which is the rate of change of v, which is same as the second derivative of displacement. So you see, there's a correspondence between the second square and dt square. Okay, very similar. Once you do this, we can then write acceleration can be written as x double dot. So x dot is velocity, acceleration is x double dot. Okay. All right, so we're going to write this. Okay, so what's acceleration? Acceleration is the first derivative of v dot, or second derivative of displacement, x double dot. So let's fill in some information about acceleration. If acceleration is positive, we say the velocity is increasing. Okay, it's increasing. And let's look at these two cases. Case 1, if acceleration positive, velocity is positive, the particle is, let's look at, should be velocity here. Okay, let's look at the, speed, the speed will be 2, 3, and 4. So it's speeding up, isn't it? So it's speeding up, speed up. Okay. On the other hand, if acceleration is positive, velocity is negative. In this case, the velocity is increasing. So -4 go from -4 to -3 to -2. But if I find the speed, it's 4, 3, 2. So what happened to the speed? It's slowing down. So we have to be careful. So when acceleration is positive, the velocity is increasing. In both cases, they are increasing. However, the speed, if it's positive, the speed is speeding up. If the velocity is negative, the speed is slowing down. So we see there's a difference. So be careful about the differences. How about the next one? What if acceleration is negative? We say the velocity is decreasing. And we'll look at two cases. Decreasing could be positive decreasing, or it can be negative velocity. If it's decreasing, become -2, -3, -4. But if we work out the speed, which is absolute value v, it's actually increasing, isn't it? So even though the velocity is decreasing, if the acceleration and velocity are both negative, it's actually speeding up. As we see here, speeding up. But if they're opposite in sign, it's actually slowing down. Okay, so this is an important piece of information. All right, note this down. Okay. Okay, after this, we'll do an example. So if acceleration is 0, we say the velocity is constant. It's not changing, because acceleration is the rate of change of velocity. And when it's a constant, the particle could be at maximum speed or minimum speed, depending on the situation. And then we'll have summarized all three new terms below. Starting with x, if we differentiate, we get velocity. If we differentiate again, we get acceleration. But if I want to go backwards, we have to integrate. Integrate acceleration is velocity. Integrate velocity, you get displacement. Okay, all right. Hopefully you all finish. We'll do one example, then you can start the work. Let's look at trigonometric equations of motion. Okay, when a particle's motion is described by a sine or cosine function, it moves backwards and forwards, and is therefore stationary over and over again. All right, let's look at the first example. A particle's displacement function is this. Find the velocity and acceleration function. So let's start with the velocity. So x equal to 2 sine pi t. So velocity will be 2 pi cos pi t. Differentiate sine is cos. And differentiate cos again gets you x double dot, which is acceleration, which is -2 pi squared sine pi t. Now notice that I don't like using A for acceleration, even though I use V for velocity. The reason why is A can be confused with the amplitude, A sine pi t. So I don't like you to use A, even though it's okay to use A, but it can cause confusion. So I prefer to write it as double dot. So I recommend you to write it as double dot to cause less confusion. Okay, let's move on. So we're going to draw these graphs. We're going to graph all three functions on the number plane below. We're going to write down the amplitude for each. So the amplitude for the displacement is 2. The amplitude for velocity is 2 pi. The amplitude for acceleration is 2 pi squared. Okay, and we're going to work out the period for each. The period will be the same for each. You just have to do it once. 2 pi divided by this number, which is equal to 2. They all have the same period. So on the graph below, I've given you graph to draw all three graphs in the space below. Okay, so draw all of these in the space below. Okay, let's draw the first one, which is displacement against time. Okay, displacement against time. So the period is 2, so let's put 2 over here. put 1.5, 1.5. Okay, so, and the amplitude is 2. 2, -2. So what do? We're going to draw the graph of sine. So it starts from 0, go to the top, down, and then we draw the graph, which is a sine graph. Right, that's the sine graph drawn. Okay, how about the other one, velocity? Do the same thing, use the fact it's amplitude 2 pi, drawing the cos graph. Maybe we'll write down the equation next to it. Actually, I need that space there. Right, just write x equal to 2 sine pi t. And the other one is velocity, which is 2 pi cos pi t. And finally, acceleration is -2 pi sine pi t. Okay, good. All right, so now draw the velocity, v against time. Notice that the amplitude is longer. That's why you have a longer y-axis. So the period is still 2. And we got the amplitude is 2 pi. So let's go 2 pi. 2 pi is longer than 2. And then we got cos, which starts from the top. 0 here, 0 there. It's 0.5, 1.5. Oops. Okay, good. So we draw the graph. Draw the graph of cos. Okay, all drawn. And then finally we have the x double dot, which is x double dot here against time. 2, 1, 0.5, and 1.5. And then we get 2 pi squared. Yep, -2 pi squared. And it's negative sign, so go here and goes downward because it's negative. Right, so note that because it's negative, the graph goes upside down. All right, all 3 are drawn, which I will answer questions about these using the 3 graphs. These graphs will come handy. All right, I'll give you a minute or 2 to catch up. Let's answer the first question. Find the times within the interval when the particles at the origin and find the speed and acceleration at those times. Let me get a highlighter. At the origin, when is it at the origin? Over here, 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 origin. So find the time. So that means when it's at the origin, you have to find the time, its speed and acceleration. So the time will be, that's why I have a table, the time will be at 0, 1 second, and 2 seconds at these 3 times. And what is the speed at these 2 times, which is the velocity absolute value? And you can use the correspondence. It's at these seconds, the speed is at 2 pi, the speed at -2 pi, and 2 pi, respectively. So you can write, it's going to be 2 pi, -2 pi, and 2 pi at these 3 times. And then what's the acceleration at these times? Acceleration. So the acceleration will be, looking at the acceleration graph, which is over here, it's going to be 0, 0, 0. Yes? So they correspond. So let me draw. Actually, I could use crayon. So here, oh, it's not very clear. Let's not use crayon. Okay, so here, here. Okay. So let's write down the acceleration. So 0, 0, 0. Okay. Okay, after we do this, we're going to find the times in the interval when the particle is stationary. Let's look at the part when it is stationary. When it's stationary, that's when velocity is 0. Velocity is 0, so velocity v equal to 0. So when is v equal to 0 at these two times? At 0.5, let's write it down, t equal to 0.5 and 1.5, these two times. And then find its displacement and acceleration at these two times. So what's x equal to? What's acceleration equal to? At these two times, the displacement is going to be, displacement will be over here and over here. So it stops at 2 and -2. So the displacement at these two times is 2 and -2. And the acceleration at these two times will be, acceleration will be over here and there, which will be -2 pi and 2 pi squared and 2 pi squared respectively. Slows down. Not letting me to write. Okay, you can. Square and 2 pi square. Let's rub this off. Okay, done. Okay, good. Any questions? So we'll leave the next one tomorrow, or next lesson to do. So you could try the next exercise today. Okay, all right, finish.